GUI, graphical user interface, to give the input through terminal is a CAE fatigue. The process remains same. So this is the general approach chart. Unless people are there, you will not understand. But one has to do the analysis of a component, an AP analysis. It has to be exported to the module, CAE fatigue module or NEF
I
module.
don't think
Anybody else use that?
in this participants list we have not used, sir.
That's okay. So I'll just to highlight how it is being taken care of. Your input file for the fatigue module is the NASTRAN FEM, that 101 what you do, or thing with the 2D and 3D. That will come to that. This is termed as a resources, means that input, and for which you have to have a SN curve for the material, then correction file. These are all available. Some of them is available. Then min stress effect, obviously that has to be done. Then load also, that is a variable, temperature and the flight spectrum. Then you have to put stress ratio, type of loading, then only life. So whatever I explained and all, this all inbuilt in a commercial aircraft, commercial software. I'll tell you when I talk about IFQ or API. So this is the like plate with circular hole. This analysis is very simple. One side is fixed, other side is applied load. You would have a loading, boundary condition, load condition and all. And this is geometry, this is geometry. Radius 6, then 50 mm length, the things, thickness is 5 mm. Then this is what during NEF you have to have a that SCAD, right? Somewhere, because you define what type of element you use and all. I am not expert in APM, so don't ask me anything related. Throughout my life, I never use APM. During my PhD also, I have not used APM, but I can interpret the results depending on what you get. So this is what you get, reinforcement, meshing and all, because it's stress concentrated factor. You need to do fine meshing to surround the hole, and when you subject to the things, you have to get the, obviously load is vertical, obviously you get stress concentrated at this point. And please remember, whenever you are to use a stress in static, you are using one misses, but when you are talking to the fatigue, it is a fatigue thing, it has to be maximum principal stress, no more one misses, because maximum you find out, because structure is subjected to multi-axial loading, then in that case you have to find the maximum principal stress, minimum stresses. In one misses thing, if you use one misses, your values, stress value will be very high, because there will be some negative thing. Sigma, your what is the equation comes, sigma 1 minus sigma 2 something to square or something like that, and in that case, in one misses you had, it will become positive, and stresses we are calculating life for higher stresses. So always please remember, when it comes to fatigue, it is always maximum principal stress. Then this is what this 1 3 2 3 is all showing the sequence if somebody is using that CAE fatigue module commercially. So you see that the file you have to open solution 101 for static analysis, and either whether you go for GUI or NASTRAN embedded thing. Then you export to that CAE fatigue. Then this is the stress. You just have a look the sequence, but is it available? If people definitely there, right? Somebody can try, or
We don't
most
have
of the
that
people will have a
module
cracked version
accessible
also.
to us, at least in aerostructures. But again, uh,
Okay, no, other personally also people probably most of us will be aware the student version, or this is a very simple problem.
okay.
Simple for this thing can be done. Student person also do. Okay, so this is what 1 2 3 the sequence. Subsequent slide will say what is the 1, what is 2. Okay, resource means that is the input file, right? File name. So it has to be either BDF and OPT. Those who are doing static analysis for 101 solution, any one of them can be used. Then you go to the material input. So there you have to either choose the material available in the database, or you can do entry as a user paid on that. So it automatically will generate a SN curve. So you can see the yield stress and ultimate strength, Young's modulus, and some code, the internal code. Then NC1 and NC2, there is a number cycle, the 2 points you are defining. One is 10 to the power 0, you can define 10 to the power 3 also. Okay, so if you are defining NC1 is what is that? Okay, it's not defined the NC2 or something like that, but it's taking a 10 to the power 0, which one cycle does intercept thing. So this is either you can pick up the data available in the database, or you can enter it from the externally. Then load whether square or sine or anything, and see that the 2 loads options are available. You can choose that. Then here that is a continuation of that. One has to go for what is the you can export also if you have external data asset available. You can export it, then you can set what is the sine wave or minimum maximum things, you can set that. Then after that thing is there, then you have to run it. So and then finally will say successful running there after but initial input what is given, these are all running intermediate one. So obviously stresses applied in this direction. So this is a high stress constant vector. Obviously one would expect the less life, other thing will be lesser life.